1945, the world changed forever. A single weapon, born from decades of scientific curiosity, would redefine war, power, and human survival. This is the story of how the atomic bomb was discovered, not by one person, but by a chain of minds spanning continents and generations. It begins at the turn of the 20th century, when scientists believed the atom was the smallest, most indivisible unit of matter. But in 1896, French physicist Henri Becquerel stumbled onto something strange: uranium salts emitting energy on their own, with no external source. He had discovered radioactivity, though he didn't yet know what it meant. Marie Curie, along with her husband Pierre, took Becquerel's discovery further. Working in a cramped Paris laboratory, they isolated new radioactive elements, polonium and radium. Their research proved that atoms weren't static at all. They could break down, releasing enormous energy in the process. This was the first crack in the wall of atomic certainty. In 1911, Ernest Rutherford changed everything again. Through his famous gold foil experiment, he discovered that atoms weren't solid balls of matter. They were mostly empty space, with a dense, tiny nucleus at the center. This nucleus held the key to enormous, untapped energy, though no one yet knew how to release it. In 1905, years earlier, Albert Einstein had published a small equation that would eventually explain everything. E equals mc squared. Mass and energy were the same thing, interchangeable. A tiny amount of mass, if converted, could unleash a staggering amount of energy. At the time, it was theoretical, a beautiful idea with no practical application. That would soon change. Fast forward to 1938. In Berlin, chemists Otto Hahn and Fritz Strassmann were bombarding uranium with neutrons, expecting to create heavier elements. Instead, they found barium, a much lighter element. Something impossible had happened. The uranium atom had split. Hahn sent his confusing results to his former colleague, physicist Lise Meitner, who had fled Nazi Germany because she was Jewish. Working with her nephew Otto Frisch in Sweden, Meitner realized what had happened. The uranium nucleus had split into two smaller nuclei, releasing a tremendous burst of energy, exactly as Einstein's equation predicted. They called it nuclear fission. And crucially, Frisch calculated that this process could release far more energy than any chemical reaction ever known. The final piece came from physicist Leo Szilard, who had already theorized years earlier that if a nuclear reaction released extra neutrons, those neutrons could trigger more reactions. A chain reaction. Fission now made that idea real. If enough uranium could be assembled, the chain reaction could sustain itself, releasing energy on a scale never seen before. Szilard understood immediately what this meant. It could power cities, or destroy them. It was 1939, and Europe stood on the brink of war. Szilard and fellow physicists feared Nazi Germany might weaponize this discovery first. Together with Albert Einstein, Szilard drafted a letter to President Franklin D. Roosevelt, warning that a bomb of unprecedented power was now theoretically possible, and urging the United States to act before Germany did. Roosevelt took the warning seriously. Slowly at first, and then with increasing urgency, American scientific and military resources began mobilizing. Committees were formed, and research accelerated. But it would take a catastrophic escalation of the war to turn theory into an all-out national project. In 1942, following America's entry into World War II, the United States launched the Manhattan Project, a massive, secret effort combining scientific research and industrial power. General Leslie Groves took charge of operations, while physicist J. Robert Oppenheimer was chosen to lead the scientific team. Facilities rose almost overnight in remote locations: Oak Ridge, Tennessee, Hanford, Washington, and a secluded mesa in Los Alamos, New Mexico. Oppenheimer gathered the greatest scientific minds of the era: physicists, chemists, and engineers from across the United States and Europe, many of them refugees from fascism. At Los Alamos, isolated from the outside world, thousands worked around the clock, driven by urgency and secrecy. Scientists pursued two parallel paths. One relied on uranium-235, a rare isotope that had to be painstakingly separated from ordinary uranium. The other used plutonium, a new element created inside nuclear reactors. Each path required solving problems no one had ever faced: enriching isotopes at industrial scale, achieving a precise, controlled chain reaction, and designing a mechanism that could trigger a massive nuclear explosion in a fraction of a second. By July 1945, after years of grueling work, the moment of truth arrived. In the New Mexico desert, at a site codenamed Trinity, scientists prepared to test their creation. On July 16, 1945, before dawn, the device detonated. A blinding flash lit the sky, followed by a massive fireball and a shockwave that rolled across the desert. Oppenheimer later recalled a line from ancient scripture: "Now I am become death, the destroyer of worlds." The nuclear age had begun. Word of the successful test reached President Harry Truman, who had just taken office after Roosevelt's death. The decision now facing him was staggering: whether to use this new weapon against Japan in hopes of ending the war without a costly invasion. On August 6, 1945, a uranium bomb was dropped on Hiroshima. 3 days later, a plutonium bomb fell on Nagasaki. The destruction was unlike anything the world had witnessed. Entire cities leveled in an instant, with devastating loss of life. Japan surrendered soon after, bringing World War II to an end. The discovery of the atomic bomb was not the work of one scientist or one nation. It was the result of a century of curiosity. From Becquerel's strange glowing uranium, to Curie's radioactive elements, to Einstein's equation, to Meitner's insight, to Szilard's chain reaction, to the tens of thousands who built it in secret. It stands as one of humanity's greatest scientific achievements, and one of its most sobering warnings about the power we now hold in our hands. Since 1945, nuclear weapons have shaped global politics, diplomacy, and the constant, uneasy balance of power between nations. The story of their discovery is a reminder that scientific progress, once unleashed, can never be undone, only managed, understood, and we hope, never used again.